To begin this tutorial, the first thing we'll do is open the file with the reference curves. When it loads, you'll see a series of curves that will help us build the model. Now go to the Curve tab and use the Line command. With OSNAP enabled, draw a line vertically through the center, crossing all the other curves. We can change this line to a different layer to keep things organized. From the top view, create a reference point. Type 0 to place it at the center of the viewport. Then, using the gumball, move that point down by 0.25. Next, we'll create an arc using cross-section. Activate the command and select the left, center, and right curves. Click on the reference point, then hold Shift to draw a straight segment to one end. Change this arc to its own layer as well. Now we can delete the reference point. Back in perspective, select all the curves. Go to the Surface tab and run Network. Leave the default options and accept to create the surface. At the bottom, switch the display mode to Shaded. If the surface looks inverted, select it and type Flip in the command bar. Return to 4 views, then hold Shift and set Shaded on all viewports at once. Now we'll create a series of curves that will guide our model. Go to Curve and use Offset on Surface. Select the bottom edge. Use Flip if needed so the arrows point toward the surface, and make the first offset of 0.5 millimeters. Before confirming, set the default layer so new curves are added there directly. Run the command again. Select the last curve created, then the surface, and make an offset of 1.4 millimeters. Repeat on the next curve with an offset of 0.5 millimeters. Again, run the command, and this time create an offset of 6.8 millimeters. Continue with another 0.5, then 1.4, followed by 0.5. Create another longer 6.8 millimeter offset. Repeat this pattern to the end, just like in the video. This way, we'll end up with 4 rails of 1.4 millimeters. Also create 0.5 millimeter offsets on the sides to define the boundary of the surface. I'm going to move the other curves to another layer to keep the viewport more organized. Once we have all the curves, select the surface and extrude it minus 1.7 millimeters with the gumball. It is important to hide the curves that cross the lanes we are going to create. Now go to the Solid tab and use Push and Pull. Activate the command and select the 4 1.4 millimeter rails. Right-click to confirm the selection. Move the cursor downward to sync the surface. If you move it upward, it will extrude, and we don't want that. Type 0.35 millimeters. We now have the 4 channels. Next, select the boundary curves that define the wider top surface and the bottom surface, as shown in the video. Hold Shift to select multiple. Switch to the top view, run Trim, and cut the 2 surfaces, separating the element into 3 parts. To close the gaps we created, go to Surface and use Loft. Select the 2 edges of each opening and run the command. If a loft is inverted, flip it. Do this for every open section. Then join each new surface back to the main body. Repeat for all 3 parts. Back to solid, push and pull again, and sink the remaining 2 surfaces 0.35 millimeters. The next step is to add gems to the channels. Go to Curve and use Extract ISO Curve with OSNAP to place a curve along the center of the first channel. For variety, we can also use tween curves. Select the 2 edges of a channel and generate a center line. Repeat this for all channels. With all center curves ready, start adding gems to one of them. Select the curve, go to Diamonds and use the Gems on Curve command. In the panel, assign the curve and the orientation surface. Use the gumball handles to reduce spacing near the ends to leave a small margin at both extremities. Set parameters. Gem size 1.30 millimeters, then click Refresh to update. Go to the Prongs tab, enable them, and leave defaults. Finally, in Cutters, choose the 3rd preset and enable it too. Now, accept the command. Repeat exactly the same procedure for the remaining channels. Rewind to this step if you need to, and continue until all channels have gems placed. To continue, I'll select everything in the viewport and type Hide to keep the workspace clean. Back in Diamonds, open Gem Studio to create a new gem. Choose Trillion, 0.17 carats, and click Add. Accept the command. Select the gem and click Basket. Without choosing a preset, click Edit. First, change the mode to Custom Shape and choose Asset 025, the heart shape. Set rotation to 90 degrees so the hearts are oriented correctly. Now adjust parameters. Diameter 1.10 millimeters, height 2.10 millimeters. Set bottom diameter 1.10 millimeters and bottom rail inside 0.30 millimeters. Go to the Rails section, disable the top rail, and edit the bottom rail. Change its mode to Custom Shape and choose Asset 004. Set width 0.90 millimeters and increase gem size percentage to about 74%. Accept to create the basket. Move the basket and gems slightly back using the gumball. Open Gem Studio again to create another gemstone. Create a round gem of 1.30 millimeters diameter and add it. We'll apply a bezel to this round gem. Without presets, click Edit. Change the profile to 002. Set width 0.90 millimeters and height 1.50 millimeters. Reduce girdle width to 0.60 millimeters. I'll switch the profile to 001 to get a rounder look. Accept the command and move the object to the metals layer. Now position the bezel next to the basket so they intersect for a strong union. Once both elements are placed, type Show to reveal the hidden content again. We'll fill the tree gaps with these elements. First, create a couple of lines to build a support surface. Draw lines connecting the different modules across the top, as shown in the video. Select the edges of the poly surfaces and the lines we just created. Go to Surface and create the surface with Sweep to Rails. Leave defaults and accept. Create the next surface the same way. Use the edges and guidelines to build it. Now start on the lower surface. In Curve, use Offset on Surface with 3.37 millimeters. For the upper surface, use an offset of 2.35 millimeters. Next, go to Transform and use the Quick Array on Curve command. First, add the objects you want to array. Then select the curve to follow. And finally assign an orientation surface. Change alignment to center and increase the number of copies. If the objects face the wrong direction, select the curve and type Flip in the command bar, then reassign the curve to the panel. Set 7 copies and adjust distance to -0.10 to bring them closer together. When everything looks good, accept. Repeat the same process on the upper curve. Run the command. Assign the curve, orientation surface, and objects. Align to center and set 3 copies. If the objects face the wrong direction, select the curve and type Flip in the command bar, then reassign the curve to the panel. For this one, set distance to 1.6 millimeters. Accept when satisfied. To continue, I feel everything sits a bit high, so I'll select all elements and move them slightly down to taste. Do the same for the lower section, and hide the reference surfaces to get a clearer view. Take your time to adjust everything. When you're happy, you can hide the basket and bezel. Now we'll make a small topology fix where our pavé will go. For pavé on surface to work well, the surface topology must match what we need. This is the topology we want. To achieve that, go to Solid, then use the Extract Surface command. In the command line, set copy equals no, and delete this surface. In the video, I also delete the top surface, but it's not necessary. We only need to change the central surface. Keep the top one as is. After deleting the central surface, select all its borders and run Sweep to Rails. You'll see the new surface topology now matches the model shape properly, except with default options. Next, go to Diamond, then run Pavé along surface. Assign the surface to the command. Click Add to preview the flow direction. In the command line, switch to V direction if needed. Set gem size to 1.30 and distance to edge to 0. From the top view, start placing rows of gems. If you press Escape to exit Add mode and then select the surface, you can see the topology as a guide, useful for finding the center. Add the first row at the top. Then add a second row. To make it fit perfectly, increase row spacing to 0.30 and place it. For the next row, continue with a row of 1.40 millimeters, then a row of 1.50 millimeters. Set spacing to 0.40 and place the last row. You can always adjust inter-row distances with the orange gumballs in the command. When you're happy, accept. To fill the remaining gaps, use Pavé Manual. Add the surface in the panel and choose a gem size that fits your space. 1.10 millimeters in my case. Place 2 stones to fill the gap. Since I forgot symmetry earlier, I'll ungroup all gems, select the last 2, and mirror them to the other side. Set the mirror center by typing 0, then hold Shift and click at the top to place the copy. Now we need prongs. Open prongs, assign the surface, and set the parameters. Diameter 0.60 millimeters. Over girdle 0.20. under girdle 0.40, and extension for manufacturing 0.60. Click Add Prongs automatically. Once it computes, most prongs will be in place, except the outer ones. Finish those manually to taste. Because the model is symmetric, you can enable X symmetry to speed things up. Remember to adjust diameters as you go. When you're done, accept. Now add the cutters. Type Cell Mesh to select all gems, then Control-click to deselect those that already have cutters. Go to Diamonds, then User the Cutters command, choose the third preset, and accept. We just need to add the top gems now. To keep things simple, hide gems, prongs, and cutters. Type Hide. Run Pavé along surface. Assign the last surface. Keep default options, and add a first row where 2 stones fit. Add 5 rows total, as shown in the video. Then switch to Pavé Manual for the remaining stones. Add 1.4 mm at the top, 1.5 mm in the lower center, 1.3 mm, or a size that fits your model, in the corner. Enable X symmetry. Add 2 1.25 mm stones, and finally place 2 0.8 mm stones to finish. Go to Prongs, set diameter 0.60, overgirdle 0.20, undergirdle 0.40, extension 0.30. Click Add automatically, and then finish the rest manually. When everything is done, accept the command. Now we are missing the cutters for these last gemstones. To do this, activate the Cutters command, then select the gemstones and add them to the command. Activate the third preset, and the cutters will be created. The model is complete. Let's add a few details. Create an O-ring and position it at the top of the model. We'll also create a star. To size it, first make a circle of 9.4 mm. Inside that circle, run Star and design it to taste. Select the star and use planar surface to create a surface, then extrude downward to taste. Hold Ctrl plus Shift, select the top face, and delete it. Select the top edges, run Round Cap, set height to 0.9, and accept. If it comes out inverted, flip it. Join the 2 star elements. Now use Gem Studio to add a 0.15 round gem. Place it by point, snapping to the center of the star. Position the gem. Create a cutter. Duplicate the lower O-ring and move it to the top. Or better yet, use bail to create a proper bail for the pendant. Accept the default bail and position it with the gumball. Once placed, edit it to taste. Change profiles and distances until you like the result. You can also adjust the O-ring parameters. Take your time to craft a bail you're happy with. When you're satisfied, accept. One final touch. Select the lower O-ring. Copy it with Ctrl plus C and Ctrl plus V. Go to Surface. Offset surface. Ensure both sides equals no. Enter 0.3 and press Enter. Now select the top section of the model. Go to Solid, Boolean Difference, and select the wider O-ring as the cutter. This creates a gap that gives the pendant a bit of movement. Lastly, perform the remaining Boolean differences between the model and all cutters. Hide the gems, and you'll see that every stone now has its seat cut. Now we're ready to render the model. We'll leave a reference render. Don't hesitate to share yours with us. From the RhinoArtisan team, we wish you happy holidays, Merry Christmas!